And for this talk, I want to bring on Ram from Openledger to tell you about how to think about the future of AI models and how generalist they can and cannot be. So without further ado, please welcome Ram on stage.
Hey guys, this is Ram from Openledger. I'm one of the core contributors here. Today, I'm going to talk about why the future of AI is specialized and not general models, right? How general models are not good enough. AI is definitely changing the way we work. We all know that AI is pretty much there in every part of our day-to-day lives, right from scheduling our meetings to taking notes for us to giving us reports of our everyday life. I think AI has been predominantly catching up to what we do. It's going to be much more bigger. It's going to help us ride the cab. It's going to help us take care of our health. We're going to see more forms of AI in the physical form as well. But are we there yet? Web3 has been always a tech which supports any emerged technology or emerging technology. We bring fairness to the other technologies that are there. And AI has been one of the biggest concentration of Web3 all these few months. Majorly starting with decentralized compute and then data and agents as well. Decentralized compute, as you know, has been pretty much covered by players like IONET and Aether. Just like how it was in the traditional space, we saw NVIDIA solving the compute problem, which led larger language to be built. On the other side, we have agents. The last few months, agents have been speculative, have been the biggest rage, but most of them have been meme-ish, right? And this is how agent era started in the traditional space as well. When ChatGPT launched, most of these agents were ChatGPT wrappers, right? They didn't have much purpose, they didn't have much utility, they were just wrappers. And then apps like Perplexity came about, which had much better utility, provide much better solutions for users' queries. AI apps and agents started to use specialized models along with the larger language models that were there, which led these apps to be much better and to be much precise than what they were compared to these wrapping agents that were there before. The current agents of Web3 are majorly memes, as I told you about. They're bloated Twitter bots with a particular persona, probably talking like a particular celebrity and tweeting about the market scenarios, insights, and so and so. We've seen chat agents where users go ahead and interact with these chats to get access, probably like a tokenized access. And then we've also seen these agents get provoked when you engage with them. We've also seen these agents experiment with trade, but most of these trades have been human created or human intended. Most of it have been having human in the loop, right? This is the current stage of agents in Web3 right now. This is what we believe the future of agents will become. And as I told you, we've seen this happen in the traditional space as well. Agents will become much more specialized. They will be focused towards a particular category in Web3. Agents will become much more adaptive. They will understand how you converse with them. They'll get to know your feedback, the queries that you put in, and then adopt accordingly. Agents will become much more proactive, right? They'll become autonomous, not much of human involved. We would see them going ahead and executing trades on its own. And then we'll also see agents share their task with other set of agents that are going to be there, like a swarm of agents which will execute tasks for you. But for this, what we need is infrastructure to support that, right? Similar to what happened in the traditional space, we would need specialized data sets, knowledge bases, and models to support these agents. I'll skip this slide because it's too boring. But most of the time, if you take a look at it, right, larger language models have been trained on internet data. 80% of this data has been predominantly internet scraped data. It has a lot of breadth, but no depth in terms of any particular topic. But that would not be useful for these agents to excel in a particular scenario. Like how humans have always been trained on a particular field to be an expert in that field. A surgeon is much better than a general practitioner. Agents similarly have to be trained on domain-specific data. Openledger enables users and builders to build specialized agents. Some of these are examples of specialized models that have been built over the last 2 years across various platforms. We've seen specialized models used in healthcare, like MedFarm. In finance, we've seen Bloomberg GPT and many more as well. We enable people to build these specialized models at scale, where data contributors contribute data sets, use our platform to build these models, and also use our attribution layer to reward back to the data contributors. What we build is a trustless layer in which subject matter experts and businesses can go forward, contribute data sets, knowing that builders will be able to use these data sets and build models and reward them back, and they'll be able to track the entire provenance of how their data was used on chain. Now let's look at how a model is being built on Openledger. As you can see here, it starts with the model proposal. A user goes ahead and creates a model, proposes the use case of this model, tokenizes this model, and also puts it under a particular category. And once these models gets enough stake and tokenized, it goes into the data layer. This is the place where models get the data that they require. Data contributors can go ahead and contribute various data sets to these models. It could be documents, it could be code descriptions, or it could just be training data sets where you answer questions. Depending on the model that is proposed, they can use our data layer to contribute data to this. The third part is once we have enough data sets, once we have populated the data repository with enough data sets for a model, the model builder decides to go ahead and use these data sets and use our no-code platform to bring back all these data sets and start fine-tuning in our platform. This is a no-code platform that uses Lora fine-tuning to train these models. These are large language models, base models that are taken, and on top of which we fine-tune a layer on top of it with more data sets, right? Think of this like we take a base product and add some customizations on top of it. Very similarly, we use Lora fine-tuning to customize the existing open source models that are there. Once you train these models, you could also use various evaluation metrics that are available in the platform. You can use our chat to evaluate these products, see how they perform, see how these models behave to the data that is trained on. You can question these models. You can ask various inputs, see the outputs that comes in, and then figure out what went wrong with the model training, and then retrain again. And probably use various other metrics that is there on the platform to train these models better. So one of the crucial sectors of this of Openledger where models get trained. Once these models are trained, once we have enough models, it goes into our deployment layer. It's called Lora, which is a framework that we've launched, which enables thousands of models to be launched in one single GPU, right? Having one GPU run one single specialized model will be too costly. So we went ahead and created this framework, which enables each GPU to run one single base model and have the fine-tuned adapters as an additional Lora fine-tuning on top of the existing framework that is there. We use Aether, Ionet, and many other GPU providers to go ahead and run our models on them. The last layer is the attribution layer, which is one of the most important aspects of our platform. This is where we enable model builders to reward the data contributors. We use proof of attribution to figure out how on every inference in a model, the data that has been contributed to for that particular inference is calculated. And then we use that to reward the data contributors. We also use that to explain the model better, right? Let's say if an agent goes ahead and uses the model and it goes rogue, something wrong happens, we'll be able to figure out which data actually caused for that particular action to happen. In certain cases, the agent could perform better, then you would actually know which data actually caused these agents to perform better. You can optimize and get more of the data. These are some real world applications that are currently built on top of Openledger. All these are models that are currently being built. Let me talk about some of these models, which are quite interesting. We have a team which was ex-Google DeepMind, which is building data intelligence layer. This is a particular model which has verticalized data sets of the internet data. They've gone ahead and taken Common Crawl and created specialized topics on that particular data set and created specialized versions of internet data. Another one is a DeFi model, which has on-chain and off-chain sentiments, which will enable DeFi AI agents to be built on top of this. We have a model which is built on Move datasets. Think of this to be a customized version of Cursor, which is a programming language model, where this particular model is trained on Move datasets, Move code, and descriptions, and so on. And we have another model which is trained on Solidity, very similar to the Move model. This also has code descriptions of Solidity code, documentations, and many more as well. This could also enable co-pilots that can help you audit contracts. So these are some of the use cases that are currently being built on our platform. I would like to end this slide with a quick analogy between us and YouTube. YouTube is a platform that happened about 10, 15 years when web needed content, right? It provided a platform where content creators can go ahead and monetize their content, contribute to YouTube, and get paid for it. Web got enriched with this particular content. Very similarly, AI needs data. Openledger is creating a platform where data contributors, subject matter experts, businesses can contribute data and index data to AI to enrich the future of AI. Thank you, guys. We are supported by one of the best people in the industry and also fellow co-founder friends. And come join us and build more on Openledger. Thank you. Thank you.